Let's look at this building again. Let's observe that these, as I understand, these are about 30 foot in height there. It's pretty significant. 3 stories tall. It's reported by the news. 30 foot off the deck. Okay. So these columns here are boxed steel, and it's like this, and it has at a few of the points like this is right here, right where one of our questioned fractures are, and I think these next questioned fractures was on this one. These are the panels they put on, the prefabs on the outside of it, hang on top of there. So like a little spandrel idea. First they build that concrete like that, and then they build I'm going to do a section of it. And the back side of it, and here's the columns holding it here. Let's be more specific. Column here. This column would be right there. This one there. Now, they put these bracing in across here, and theoretically, it's supposed to take the load back to here, which then takes it back to the column. Why would it do that? Why would it do that? It's like an extension of a porch, but we want to see if there's any rotation in this one, any fracturing, any rotation. Let me get to, let me clear this up. And on this side of the building, I want you to take note of these steel columns, and they're on the roof, and they've got coating on them to protect, to make them waterproof at the base. They're riddled across here, right? Let's go from here. So here's the other side of the building, which is quite hard to get. This looks like some construction debris, so materials, so they're not finished, but we also see that it has presents these supports here. I call it supports, but they might be a decorative curtain wall. It might not be structural, just hiding the equipment, as you see there. Okay. At one point, if this spandrel detail, the exterior here, starts deflecting, they will take on a load. These fractures don't look like that. They look like torsional fractures, and I'm going to show you a video on that in a minute. But not to be confused, I want you to see these columns here on this side, this steel here. And I'll show you why. I want you to know that in a moment. And that's because on Google Earth, it's a little bit tainted. It looks like it's removed. With that said, it looks like we can see through a little bit. We can come up to the top, and we can look at what's going on also. So let's go to, I believe it's this one, and maybe this one. What do they have in common? They're the full supported column supported sections. So column down to the concrete, for the concrete column, not that metal. I believe they're underneath each one of those. So coming across, I think we have them here. I showed you a roof video in video 1. I've since made video 1 into private because I think this is not plate slab construction. I think this might be it's some plate slab on it, but it appears there's some double T's construction. It looks like this. Like that. It might be double T. It could be, a bunch of singles, and they put concrete over top of it. But I remember finding that video, where I see them pouring at night, and it's almost like they're doing that recessed beam, pouring it. But I don't see them doing all of that. So I just can't be sure about it. I can't be sure about the just plate slab. And we move on, but I do see that they're loading it. If it's the T section, they're loading it pretty significantly on some cross beams. Looking at this, we don't see any direct loading on top of these cross members. We don't see any direct loading on top of it. You don't see any water tower or anything else like that. But can it be something hung from it, like the bracing? I think this stands from the roof on the roof deck down below, because I have an image of that. I think that's the way that works. So now let's go back to putting these back in. There's a column, and I'll do one on each end here. And the next, I don't know how much of an overhang this section is. I don't know how much of an overhang this section is down here. But let's go column there. All right, so we know they go through. So these are ones in question that go through. All right, that I think are in question. But we got this little guy here and a little guy here. How does it transfer the load out to the columns there? Well, let's put this in. Let's tie this in. Mapping some fractures. Let's put a little slight fracture. Nope, wrong one. I think it's back here. Slight fracture across the intersection there. So thinking about torsional buckling and how this, they need a surveyor up there to check elevations of this stuff to see if it's flat, level, and plumb. All right, so because I'm seeing torsion rotation on this one right here. I showed you that in video number 2. What can these do? If you imagine, if I could just load it out here, which I can, if I can load it out there, I'll start rotating it down, and that's going to pull on the back of this beam here going across. So I'll put some stress there. We see no brakes there, though. Here, inside there, no brakes are indicated. So let's just say it's really a good support system. But if it is really integral, but what if this was rotating a bit? Well, we'd want to see some fractures like that inside these. This one is like this. It's don't exaggerate it. It's like that. It's not like this, in that direction. So I don't know if we have any rotation there on that one. But it would be nice, again, to have a surveyor up there and determine what's plumb and everything exacting. And of course, checking it for rebar, somebody to check the depth of rebar with some sound, with some equipment. How about that? So part of this spandrel weight, this exterior wall weight, could be intercepted by that steel wall that's down here. That's welded. We saw the welds in video 2 to the underside of the cantilevers. The underside of these cantilevers, they welded. They welded and secured it. Presents as welded and secured it. Otherwise, maybe the wind would just flap it and knock it over, because it would have to be anchored at the floor only. They're 30 foot tall. They're significant in their gridding. So it's got a significant wind resistance, all the surface area, if you're getting wind across it. I know a lot of wind would go through it, but you still count the surface area. So I don't think it's for free. So they probably do have it secured there. You would check the floor. Of course, surveyor would do that and say, look, the floor looks like it's dipping over here. In this case, the dip of the floor I would look for, and this is all cantilever stuff, the floor, this system, let's do the floor, let's pretend like it's the floor. This system cantilevers out of the structure. The beams are back here. The floor extends out. And it's out here. This floor is extended out. Extended out down here. I'm not sure how much of the floor. This is the outside wall. So this is the extended floor, I think, out to there. And that's that decorative piece there. Lighting, whatever the hell it's for. Whatever the engineer got their architect got their inspiration from. Halls of Justice, I don't know. So the torsion is there. Now let me get to let's talk about that. So this side, Seems to be in equilibrium with this side, meaning it's symmetrical. So why can't we find fractures over here? Why don't we find the same fractures, or they're not reporting to us the same fractures? It appears to be supported roughly in the same place, only based on the one image I have there, not through measurements. I don't know that. What do you have going over here? You do have a machine that's anchored there. I'm sure they have some isolation. I feel confident they have some dampers over there to help with the vibration. But for the hell of it, take some vibration, with this equipment running, take some vibration measurements off of every single piece of concrete here, not just running. Every single piece, and map it. It's for free, get up there and map it. Remember NIST did the little bars on there and tapped it? Well, you can do real sounding equipment that you can put in each location exactly the same. And you can profile this whole beam, high and low, all the way back, all the way across, and all the way across here, and all the way down here, and see if on this side too, see if what you get over here is different. And think about the frequency. Did you match the frequency of that concrete? That if it's any vibration there at all. Let me move on. I'm gonna just draw this in roughly right here and there. Again, can this load can this beam transfer this load back to here and then back down the columns? Can it do that? Can it do that, or is it not doing such a great job, and instead of going this route back to column, it's going this route back to column, creating excess loading and torsional, rotational buckling in that one? Where's this one? You can pick your poison, either one or the other. It's still the same difference. Is it making it this load path I just showed you? Is it going that way? Or did they happen to make it just so perfect that this says my load path is this way, going the other direction, overloading it there, and maybe on this side it does the correct load path like that, down here in this direction back to column. Maybe that works great. Maybe this one out here does a different deal. Maybe it doesn't. Maybe the distance, the spans, are so with the column. Remember, you got those bracing underneath, those steel pipes. Maybe they are what I call intercepting the load. Remember, it's like a car being on all four tires. I put a jack underneath the car. I start jacking it up. I intercepted the loads off the tires. Well, maybe the intent is to go back in that red path I'm showing there. But maybe some of that steel is shimmed up so perfectly that it's redirected the load path to this, maybe it's like this. It's just a thought, all right? I'm not living and dying on this one. But I'm just showing you that, yes, you automatically assume, okay, it's going back there because, hey, that's the way it should be. It's just back in the building there. But this might be a candidate for, you reverse directions of your own damn support. You reverse the direction of it by mistake because of intercepting it like a jack on a car, using the long column, I don't know how tall they are, the tall boxed beams. Now, if they're loose, and you can show they're not touching anything, not really touching, intercepting a load, great. Still consider, though, did it get intercepted? So even if that's not doing it that way as a load path to change it, that would be load path. That would be a load bearing. It would be it would be intercepting the load. It would be load bearing those beams down there, those columns. But if it's not doing it, still look at, did it just go the pink direction? And that pink direction coming around the outside could create that torsion buckling issue. And if we come the other way, back the red pathway, then it's going. Then back here is where it's great. That would be taking all of this load. Well, not all of it. Let's just say it would be taking, this much of the load back into the two columns. That would be nice. That would be ideal. But what if it's not? So column, this way, and then there's one there. What if this section is not going back this direction to loading? What if it's saying, you know what, I got you, yeah, you're there, but actually I see the interception of the load path in this direction. Sorry, that you wanted me to see it the other way. I just don't see it that way. And that would be overloading. Looking to the left, you would try to see if you can see that, duplicate it, and wonder why it would do that. Can you find out that, the one to the right compared to the one to the left is 3 foot longer? And they thought that 3 foot longer would be no big deal. So say this is over here, say this is 15 feet, and these are 18. Maybe that's perfect for what we're looking at now. It created the perfect storm, if you will. All right, let me move on. So it took me forever to find. I said I would try to find it in someone's content. And we look at longitudinal bars, stirrups, cracks, and as they identified, torsion and beams. And you see that we have this. But more so, I have that one where I'm showing it's rotating. Where I'm showing that this section is further out of plane than the section behind it. It's a gap there indicating rotation. And in this case, it would be, rotational torque. But it's causing a problem. Could be the size of the beam that's perfectly in balance. But remember, I've got the other side. You've got to look at the other side. If the other side and this one are exactly the same, without worrying about, excuse me for the hiccup, without worrying about the intercepting with the columns, those blue decorative curtain wall, then I have that path going that weird way, coming back around the outside, like the song, coming around the outside. All right, let's see if I can find you an explosive video with showing what it looks like. Okay, so I found the video, explosive failure mode of, all right, your concrete there, beam specimen under torsion. All right, I've already watched the video. It's going to be here. Before you do that, though, take note of the fractures. Take note of the fractures. And this part they made stationary. They clamped it down. And this is a tooling that's going to force this lever to go up. And, all right, so this is clamped down. This lever's up. Maybe the layman would say, it's going to rotate right here then in the middle, because it's rotating from one end. This is clamped down. It goes to the middle. Yeah, that's not the way it works. It's not the way the failure works. It's like a screw at this point. And the screw, our failure zone is right here. Let's go ahead and maybe I can catch it. All right, so you see some spalling off the bottom. So you see the spalling off of there. Okay. So you see the explosive action. So that was internal force. Internal forces were there. And then when it finally let go, this is what I talk about rebar, that it holds. It really holds great until when it finally lets go, when that maximum handshake is released, it's explosive. It ejects the concrete off of it. All right, it's an tension that's so great, it blasts it off, and that's why you can see the two in CTS, for example, those two pieces of rebar there hanging by the door, cleaned off. That means that it also had internal forces built up to the point where it finally exploded. The concrete exploded off of it. And that tells you a lot. I'll give you a little sneak peek to that. That tells you that It was over top of the column, and the integral of G, this part of G, was still integral. When G went down, it pulled on that beam, 102 I call it, and it pulled on it, and it held until it couldn't hold anymore to it, got this explosive break, and we see the two pieces of rebar with the 90 still pretty much intact, and with the deviation off to the side. So it tells you which direction. All right, so in here, you see the stirrups. All right, you're looking at the stirrups there. I'm going to move it out of the way. Maybe top steel. Pretty high up if it's top steel. There is, oh, that's part of the rig. I'm sorry. Part of the testing rig. And your rebar, your is there, maybe some here at the bottom and one's at the top. So you might have put two pieces in there. This is rotational torque. It's, if you look at it, a steel beam. If you think of this as a steel beam, a boxed beam, but it's solid filled, you would understand it, or you can start visualizing it a little better. The reinforcement is close there. I like that. It's nice. Not 12, but maybe 5 inches apart, which is great. Okay, so now you're looking at that. Let me back this up again. Okay, so you see the explosiveness of it, the concrete cover, the explosiveness of it. So this is what's going on with that. I think there's some rotational torque in there, one way or another. I know it doesn't look that way because you have that outside spandrel that looks, that's why I said surveyor. You need a surveyor out there that says, you know what, this does have a profile of a dip here. Maybe it's 2 inches, and it extrapolates out to, you're seeing the fine, what you look as it's flexural, or a lot of you guys might call them tension fractures, but you've got all these going on like that, right? Similar to our rotation at the on this beam. So now you know what concrete rotational torque looks like, rotational torsion, and you know what it looks like on the failure. So now we come to this one, and you now see the pattern. All right, but number one is you see this. It's at a plane. It's not fractured as in this side is dipping down, and then you see an open fracture here. You don't see I'm exaggerating with the openness, but they're not open like that. You've got this action going on like this, which has, and number one, you've got this one rotated towards us, this section towards us, section 2, section 1, it seems to be stationary. I can't tell, we can't see back here. For all I know, section 1 it did the rotating, and this stayed stationary. But you're getting, it explains why you're getting all these crazy fractures of all different directions. Multiple directions. And again, the efflorescence you see here is indicating that this was going on. It had water dish issues here for a long time. These salts don't develop in a year's time unless you got some serious ASR, ACR, however you like to look, alkaline silica reaction, ACR, if you like to call it that. You've got some serious reaction there. Is it on the other part of the structure? Also, doesn't appear to be coated. I mean, it's just some pretty interesting dark patterns here. Is that coming from the AC units? Is it drafting down, hitting that little louvers and coming back and making this interesting pattern? Very interesting, the coloration. It actually helps with mapping, as you can see the depth in it. You can see this depth a lot better. This would have not been black. Typically not been black. It would have been the stone aggregate you were looking at, but this profile as well, considering the photographer did, had good white balance, which just looks like a good color sky, and these look about right. So this is where I'm getting this torque, this rotational twist at the very top. And maybe it's that back way around. Maybe. So this is where I think it's the building. Can't be sure. But if this is the building, these are the columns, and that's that right down to the floor. That's your extension out. That's your cantilever flooring going out. And this would be one of those cantilever type beam actions that they actually put on the top roof. And so you'd go looking for these other floors to see. So yes, we're looking at the top floor only now, but perhaps they need to open up some ceilings and start hunting for all the other floors to see if they exhibit the same, especially because it appears they have this floor beam going across, tying into it. So this one here, I mean, I can't, I could be looking at ghosts, but it looks like it's a floor beam. And then you have the outer spandrel one out here. So this may look small on the top roof, but it looks like you're going to have to go through both sides of the building. Every floor, every one of these little outriggers, if you will. Outriggers. Outlookers. Every one of these cantilever reinforced beam girders. All right, so I added that. It's beam, girder, and I'm calling this the floor joist. And then the out one would be spandrel, tying into here. And then here's our structure here, load path. And then we got this coming across. It doesn't look like T-beams. It really looks like it was poured in place, because I'm not familiar with a T-beam that's so sharp like that. And I don't see the typical floor beam separation where you butt them together. I don't see the anchorage. I don't see the weldment. This is the only photograph I can find like this close, this intense, this close up. And I can't. Those are sprinkler systems, things like that. I just can't find it. It makes me want to believe that they poured it in place. And I will say that this looks like it's the same size as these. And if that's the case, that entire floor section, let's call it, you can do the halfway if you want. I don't believe in the halfway crap, because I can't take this section out and this section stay behind. So I believe it still loads back. It's all party to going back to the wall section. With my theory, which is 100% solid, because you can't cut your section out. No matter what you say, well, that section loads here and this loads back there. Yeah, to a degree, it loads back there, but you can't cut it out. You can't cut my section out and yours stay. It needs my section in. So with that said, this beam is pretty much going all the way across the entire floor, taking the load of the entire floor here. And it looks so small. The only difference, I can't really tell the depth of it, the girth of it like that at the bottom, but this is only sticking down a few inches below the depth of this floor beam. Floor joist. And then they would have poured it. Maybe they would have poured it. It's interesting to say the least. That changed the load path to mostly back this wall here, down this column. This column is not doing much for us here at this section, because it's not even, this beam's not even touching. It looks like it's daylight. But number one are these guys here. So number one, it looks like they have to take apart every single floor and inspect every single one, just for the general principle of it. And they can monitor it with a high dollar cameras. In other words, they can put cameras on all these and not have to worry about it. They, all the money they make from the courts, all the money they make from everybody that they've, arresting and charging fees for, they can put cameras on each one of these without using sensors. They can literally put cameras on there that they can flick through each one, and you can hit every single one. Yeah, there's 20 floors. All right, so there's I don't know, 300 cameras. You can go through 300 cameras, put them up there for a year, do your observation, 2 years, 3 years, forever. I mean, they got cameras in every room. You know that when you go in these buildings, they got all the money to put cameras every damn where. Well, get some cameras in there. Forget the monitoring system. Go for the visual. You would think though that some of that torque would reflect in the glass breaking, but that's not the way it works. Glass is pretty damn flexible. All right, there's your other. So I said I'll be back, but there's your beam there, and then so here's a beam here, and so there's your floor beams here. So taking a better look at that. But I'd like to end the video to tell you that I think if this is true, this is the building, they need to get in there and look at every single one just because. And if you determine it's just water related up top, that's great. But you need to take out those drop ceilings and bounce around on each floor and give each floor the respect it deserves for human life. Take care. I know it's a tough one, drama wise, but tough luck. Oh, for you guys, that's plywood. It's a plywood seam there. It's a seam. What else can I tell you? That's it. I mean, we're looking at the floor, but I can't tell. It might be concrete coated. When looking at the floor down below, I can't tell. It looks like it's coated with like they added concrete veneer on top. Whatever. Love you guys. Bye. I think I'm going to look through a couple more images, but probably terminate video. Okay. So I think this is worthy of pointing out. As you see, this goes out. And I'm having fun. Do you see the concrete column there? Neither do I. Over here on the structure, though, I see the concrete. Okay, I see the concrete going down on the outside of the building. It looks like right on the edge of it. It looks like it's right on the edge of it. But when I looked through the other image there, I did not see that. I don't see the concrete columns here. It looks like we're in the inside section, because it looks like the other wall back there. So perhaps on our is the air conditioning unit end? On our failed side here, we have our exhibiting as failed side. Maybe we do have a transfer of columns all the way down to the base like that. And on the other side, maybe they have that cantilever idea with the spandrel and the one floor beam between them, and then back here the beam support. Maybe they do that every now and then, like that. I don't have enough photographs. I'm ending this video. I just need more images. I'll do corrections as I can, as I find data. I'll do corrections, but this is something I want to share with you. And that sharing is this: that these all need to be inspected on every single floor. IMO. That means in my opinion. Bye. Love you.